right, so here's another example from chapter 2. So this example is one of the problems from the textbook. So we've got a bolt that's subjected to a force. The force there is shown as F, and they want to find the components of that force acting along the X, Y, and Z axis. So you're essentially taking a force and you're dividing it up into uh, its components. So when you are given, there's three ways, right, that we can be given something in three dimensions. The last example we did is when you're given the points. The other way is you can be given a force value and angles between the X, Y, and Z axis. If you're given that, you can use directional cosines. And you can see here's how we can get Fx, Fy, Fz if you're given all three angles. That comes from the definition of the cosine squared for each of those three added together is equal to 1. So there's a little trick here, right? First off, right, they hit this alpha, beta, gamma stuff. Uh, I like the theta x, theta y, theta z, which I've translated that to here in my solution. Right, we've got theta x, we've got theta z. We don't have theta y, so we've got two of the three pieces, right? We need to know the x, y, and z piece. We can't get the third piece directly. So what we can do is we know theta x and no, we know theta y, and we know theta z. No, we need to find theta y. Forget that. We know x, we know theta x and theta z. I was correct in the first case. So we can plug those values into our cosine squareds. Right, so we put in the 60, we put in the 45, we don't know what theta y is. We can solve the equation. We find that theta y is 60 degrees. Now we have all three. We can take and simply plug those in, multiply the 80 newtons times the cosine of those three angles. Interestingly enough, two of those have the same angle. However, right, I have a negative answer because if you look at the original problem, which I can't go backwards when I do this video, you'll find that the direction happens to be in the negative y direction, right? The x component is positive, the z component is positive, but the y component is negative. So the negative sign in this case denotes direction. So if you're given angles, you simply take the force and multiply it by the cosine of the three angles, and you'll get the component pieces of your force.